Vocal check 1, 2. Okay, we're rolling. It's after 9 o'clock. Out of respect for everybody's time that's taking the class, I'm recording the walkthrough presentation on the lab 4.5.2, which is doing inter VLAN routing between two switches and a Cisco router. So the first thing I'm going to do is we're going to bring up these two switches and router and make sure that they're erased and then start configuring it. All right, so let me see. I'm going to, let's see, we are recording. Good, we are recording. I'm going to bring up the other tear term. Okay, I'm going to minimize this. Okay, so the very first part of the configuration we're supposed to do after the wiring is completed is to configure basic settings on the router. So I only have two COM settings, two COM ports on this computer. So I'm going to use the bottom one for R1, and then I'll switch the S2 to it, and S2 will be the top one, and S2 will be the bottom one when I move that bar over when I swing the wires. So we're supposed to console into the router and go into the privileged exec mode. Now let's first of all, let's make sure this is an erased router. It appears to be an erased router. It's just asking us if it wants to be configured. So I'll go and press enter on that. Hang this a second while it completes that configuration. Typically, when a router asks you if it wants to be configured or not, it's a sure sign that it doesn't have any previous configuration. It does have the default host name of router, but let's go ahead to go to the privileged exec mode and let's show the startup configuration. And we see that nothing is there. And if I type show IP interface brief, nothing is configured, everything's administratively shut down. Okay, so good. So we're going to assign a device name to the router, first of all. I'll go to the global configuration mode and say host name R1. I'm going to add a couple of steps in here to the lab that he doesn't do in there. I like to use Cisco Discovery Protocol to make sure that everything's configured properly. I'm going to go ahead and go to that interface. What I like to do is tear off the front page of the lab, so I can see all the interface numbers and configurations without having to flip back where I'm following here for you to see on the screen. So I'm gonna do a device name. Now, before I do the remaining steps, I'm gonna go ahead and take that G0001, I'll say interface gigabit 0/1 on our routers. It's G001 on the new 4000 routers. We have the 1941 routers. It's G01 on that. So take note of that when you do the commands. If you're doing this on Packet Tracer remotely, you can provision the 4321 series router, the 4000 series router, and the interface numbers will match perfectly if you're doing that with Packet Tracer. I advise you do that. Okay, what I'm going to do is I'm going to go ahead and do a no shutdown on this port. And then that way, when I do show CDP neighbors later on, it'll show up and we can make sure that they're connected together. All the wires are connected together properly. Okay, so I gave a device name to the router. Now we're supposed to disable DNS lookup. So I'll go back to the configuration mode and say no IP domain lookup. And that way, if I make a typing error, it won't hang me up for a moment. Now we're going to assign class as a privileged exec mode. So enable secret class, and then assign Cisco as the console password. So line console 0, password Cisco, login, and then line PTY 0 through 4, password Cisco, login. Encrypt the plain text passwords. So that's the command service password encryption. The enable secret class is already encrypted, but that encrypts the other ones so that we do show run. You won't be able to see the plain password. No one can look over your shoulder and see that. Okay, banner message of the day. Banner MOTD. I'll use the tic-tac-toe sign as the delimiter character, and you could put whatever warning that your company has made you to put there. Save the running configuration to the startup configuration file. So that's the command copy running configuration, startup configuration. Twice. I'm going to skip setting the clock just for the purpose of time here. Okay. Now I've configured this. If I do a show IP interface brief, The only thing we've done here on the gigabit 01 port is we did a no shutdown. It's up and up. We haven't assigned MAC addresses. It's going to have us do that yet because we're going to assign subinterfaces. Now I'm going to swing cable. So I moved my console connection from the router R1 that we just configured to the switch 2, and let's configure the 2 switches here. So I'm now in step 3 in the middle of page 3 of the lab. And we're going to go to the privilege exec mode and go to the global configuration mode and give this guy hostname S1. And we'll repeat all this on S2 when we finish with this. No IP domain lookup. So typing errors aren't a problem. Enable secret class with enable password. So line console 0, password Cisco, and login, and then line VTY 0 through 15, password Cisco, login. Encrypt the plain text passwords. So I'll go back to configure terminal and say service password encryption. Takes care of that. Create a banner message of the day. Google warning. I won't mess with the clock, and I'll save the configuration. So copy, run, start. That's a shortcut. We'll work for that. If I do a short IP interface brief right now, in this particular lab configuration, port 1 is connected to the switches. Port 1, the switch automatically brings ports up and up if there's something plugged into, causes the link line to go up. On a router, we have to actually do no shutdown command. Port 6 goes to our PCA. Port 5 goes to the router. And I did it up and up on the router, so it should be up and up as well. Now we're going to repeat this configuration for switch B. Okay, so I flipped the wire back over. We're now on the router, or the switch, not on the router. So I'll go to the privilege exec mode and configure terminal and hostname S2. We're supposed to do no IP domain lookup. And then we're supposed to say enable secret class, and then line VTY, line console 0, password Cisco, allow logins. Hello, we're taping, go and have a seat. After I go through taping the walkthrough, I'll get you going there. Line VTY 0 through 15, oops, line VTY 0 through 15, password Cisco, login, and then we're supposed to encrypt the password. So I'll go to configure mode and service, password encryption, and a banner message of the day warning you. Okay. I won't set the clock in the interest of time, and then let's save this. Okay, now we're going to configure some PC hosts, and so let's see here. I have to find my VMware and start it up. And we're going to use PCA and PCB. So I'll start at PCA, and I'll start at PCB. And then we'll go back to PCA and configure their host information that was given on the front page of the lab. So we'll give the machine a second to boot up, and then we'll do that. PCA is almost booted up. PCB is almost booted up. We'll go in here and we'll apply an IP configuration from the front page of the lab. Okay, so I'm going to use the shortcut that I provided on the VMware. If you're doing this at home on Packet Tracer, you will of course use the PCA, PCB, and the configuration is similar to this, except there's a different kind of a graphical utility. So I'm going to go to the Cisco Lab shortcut and go to the properties and go to IP version 4, and I'm going to clear it out and it's supposed to be PCA is specified to be 192.168.20.3. He automatically fills in the proper subnet mask. We do need a subnet mask here. I mean, we do need a default gateway here because you're doing VLAN routing with a router this time. And so his 20.1 will be his default gateway. Then you have to click all the OKs. Click the first OK, click the second OK, click the close. And let me go to the DOS prompt here just to make sure it took, because sometimes on VMs it's flaky. 192.168.20.3, 255, 20.1. Oh, good. I didn't do any fat fingered stuff. Okay, and I'm going to flip over to PCB and we'll configure it according to the front page. So I'll bring up the TCP/IP properties, wipe out the previous configuration, and PCB is specified to be 192.168.30.3 and 192.168.30.1 is his default gateway. Okay, okay, close, and let's verify with ipconfig. Okay, 192.168.30.3 is okay. 192.168.30.1 default. Okay, so the PCs are configured. Now we're going to go into the switches and add the port 6 on the switch 1, port 18 on the switch 2 that these guys are connected to and make that come out. Okay. Okay, so I've done the PC host. Now I'm at the near the bottom of page 3, and we're going to configure the VLANs and the switch ports. All right, so I'm going to temporarily, well, I'm just going to bring the switches back on top. Okay. Oh, what I wanted to show you here is a thing to check to make sure everything's connected back and forth. Switch 1 is our switch in the middle. So if I do a show CDP neighbor, I can see that my switch 1 is connected to switch 2, port 1 to 1. That's proper. I can see that R1 is connected to my port 5 to his gigabit port 0/1, and that is in fact what the lab topology calls out for. So I'd like to show Cisco Discovery Protocol just as a quick check before you delve into a laboratory and you figure out, oh, the one wire was connected wrong or something like that, and you got to stop and do stuff over again. That's discouraging. Okay, now we're supposed to assign switch ports on the front page of the lab. So step 1, you're on the bottom of page 3, says create and name the required VLANs on each switch from the table above. So the VLAN table is given here. And in the interest of time, I'm only going to do 10, 20, and 30, and I'm going to skip the 99 and 1,000 and the port assignment for that, so we can step through this lab walkthrough more quickly. So switch 1, we go to the global configuration mode, and then I'm going to say VLAN 10, name, management. Create the VLAN, I haven't signed the ports to it yet, I have to do that. VLAN 20, name sales. VLAN 30, name operations. All right, so if I check this, or I do show VLAN, we created VLANs 10, 20, and 30, but we haven't assigned any ports to them yet. Okay, he told us to create and name the VLANs. He hasn't told us to put anything in the ports yet. I'm still on switch A. I have to repeat the stuff on switch 2 in a second. Configure the management interface and default gateway on each switch using the IP address information in the addressing table. So switch 1, we're on switch 1 right now, and we're going to go to the global configuration mode and say interface VLAN 10 is a management interface. And switch 1 is IP address 192.168.10.11 255.255.255.0, and then we need to do the IP default gateway command. We'll have connectivity from other networks. So IP default gateway for this is 192.168.10.11 10.1 is the default gateway for the switches. Okay, but before I go to the next page, I'm going to go ahead and repeat the stuff on the switch, the second switch. So let's create the VLANs on the second switch. Go to global configuration mode, VLAN 10, name management, VLAN 20, name sales, and VLAN 30, name operations. You guys recall when you did this lab last time, you had two PCs connected on two separate VLANs and they would not ping each other. We had no router. We're going to put the router in today. They will all be able to ping each other. The switches could ping each other, but they couldn't ping the PCs. The PCs could not ping the switches. We're putting a router in here now. Everything should be able to ping. Any switch should be able to ping any other device. Anybody should be able to ping the switch after we do this inter VLAN routing configuration on the router. We haven't done that yet. Okay, let's see. I created the VLANs. I've got to create the management interface now. So configure terminal, interface, VLAN 10, management VLAN, switch 2, yeah, VLAN 10. IP address, 192.168. And switch 2 is 10.12. And then go back to the pure configuration mode. IP default gateway is 192.168.10.1. Now this is a test here. My address is on switch 2. I'm 192.168.10.12. Can I ping 192.168.10.11? No, not yet. Haven't assigned any ports yet. Okay. Okay, let's go to page 4. And I'm going to repeat all these operations on both switches. So let's assign VLANs to the correct switch interfaces. I'll go back to switch 1. And according to our table here, on switch 1, we're going to go to interface past Ethernet 0/6, and he should be switch port, access, VLAN, what number? 20. Okay. Now let's do the switch 2 and do his port. So configure terminal, interface fast Ethernet 0/18, switch port, access, VLAN on switch 2, that's 30, his operations group. Okay, let's check and make sure that worked. So we'll do a show VLAN on the second switch, and port 18 has been moved into VLAN 30. Okay, that's what we wanted. Now we'll go back to switch 1 and do a show VLAN. Switch port 6 has been assigned to VLAN 20. They can't ping each other yet. We haven't configured trunking. We haven't done anything to the router yet at all. I have to do that first. Okay, so we verified the VLANs are attached to the correct interfaces. Now let's configure the trunking ports between the switches. Salud. Okay, so if I do a show interface trunking, there's no trunking right now. Port 1 is still assigned to the default VLAN number 1. So let's go to the configuration mode and say interface fast Ethernet 0/1 and switch port mode trunk. Now to make it a trunking port. Now because we're dynamic auto, the second switch will automatically trunk up to us. Shouldn't have to make it trunk. So let's check and see now. If I type show interface trunk, now it says that port 1 is trunking. Now what about switch 2? We didn't type any commands on switch 2. What's going on with switch 2? Show interface trunk. It's already trunking. Dynamic auto. Dynamic auto will automatically trunk up to an unconditional trunking port, so we don't have to do that. Okay, I'm going to skip the native VLAN stuff. We'll just, in the interest of time, we'll leave it on VLAN number 1. Line interface on protocol 10 has come up, change state to up. And normally a VLAN will not come up and up until you have assigned a switch port to that VLAN and cause it to be up and up and up and be able to ping from it. Okay, he does tell me in the next step, step 2, to manually configure. Oh yeah, we got to configure port 5 to go to the router, because the router is going to be expects trunking communication. So let me do the same thing on the router. I mean on the switch to the router. Okay, so I'll go to configure terminal interface fast Ethernet 0/5 switch port mode trunk. It should be trunking. It says what happens if G000 on R1 is down? Well, I brought it up again. I brought it up before to check show CDP protocols. So let's see if we do a show interface trunk. He thinks he's trunking. Okay, good. That's what it's supposed to be. Now let's configure inter VLAN routing on the router. And I'm going to have to swing my cable from S2 to plug it into the port, because I only have 2 COM ports on my computer here at the teacher station. So now I should be connected to the router, and the router was no configured. Oh, we did some initial configuration, didn't we? Okay, Cisco enable class. Okay, so we're attached to the router. If I do a show CDP neighbor on the router, he tells me he's attached to switch 1. Good. The router's supposed to be attached to switch 1. Okay, let's configure sub interfaces for the VLANs on the router as specified in the routing table for R1. So at the top of that chart there, on page 1, the addressing table, we're going to go and do this and configure terminal. And so I'm going to say interface gigabit, and I have to say 0/1 instead of 0/01, because our routers only have 1/ instead of 2.10. And the IP, before I give the IP address, I have to say encapsulation .1q VLAN 10, because they won't let me do the IP address unless I do that first. So the IP address is 192.168.10.1, 55.255.255.0. I don't have to do no shutdown on the interface ports. I just have to do the no shutdown on the hardware port itself, and I already did that. Okay, now we're going to do the second one, interface G0/1.20. Encapsulation .1q VLAN 20. The address 192.168.20.1. That it? 255.255.255.0. And then we'll do interface G0/1.30. Oops. 30. IP address 192.168.30.1. 255.255.255. Oh, he's not going to take it because I didn't do the encapsulation command first. We have to tell it encapsulation .1q or ISL, because the router could be connected to an old switch. So that's why I have to do that first. Q30. Now I can repeat that address. Repeat that command, and that's configured. Verify that they're operational. Okay, well, let's check show IP interface brief. 10. Make sure I didn't fat finger anything. 10.1, 20.1, 30.1. Everything's on the up and up. And how about show the routing table? So we have directly connected networks, the 192.168.10.20.30. They're all directly connected as sub interfaces or logical interfaces. So it looks like that's okay. All right, now let's see if we can do some pinging. I'll go back to my VMware. Let me go to PCA. In PCA, I'm a 20.3, and can I ping 192.168.20.1? Whoa, ooh, it's working. Ooh, all right. Now, can I ping from PCA to PCB? Ping 192.168. Let's see, PCB is 30.3. It works. I can ping from there. Now, can I ping the switch management address? Maybe PCA. You're the IT guy, PCA. You're supposed to log into the switch and do management on it. Well, what's the switch's address? Let's see. Switch 1 was 192.168.10.11. Uh-oh, bad magic. Can't ping to him. Oh, there it is. Okay, I almost had a heart attack there. Look what happened. Why did the first one not ping? Our timeout address resolution protocol typically causes the very first ping to fail. If I do it again, it's just fine. And I'll repeat the same thing on port .12, the second switch. Art failed the first one, and now it's fine. The second set of pings will be just fine. Okay, now let's go to PCB. He wants me to go to PCB and do some stuff. From the command prompt window of PCB, issue the traceroute command back to PCA. So on Windows machines, it's not traceroute, it's traceroute, T-R-A-C-R-T. On Linux, Unix, on Cisco devices like routers and switches, you spell the word trace or this word traceroute. Trace is a legal abbreviation for traceroute. And he says the address is the address of PCA. 192.168.PCA is 20.3. Okay, so traceroute is like ping on steroids. What it's doing is it's checking all the routers that are between all the devices and giving me a report back to those. For example, typically when you go on the internet, there's maybe 10 routers between you and the web page you're going to. So it pinged back, it went back to the sub interface 30.30, went back to the sub interface .20, and the trace was complete. And what intermediate IP addresses are shown in the results? Well, the 30.1 and the 20.1. Hey, we've completed the lab. Okay, hang loose. I'm going to stop recording.